Okay, so let's take a second and look at factors that can affect enzyme activity. Several factors affect the rate of enzyme catalyzed reactions, and it's a field that's been advanced in part by the pioneering biomedical researcher Maud Menton, and you can see her picture here. And she made several contributions to quantifying these processes that we're going to take a look at in this video. Now, the most important factors are enzyme concentration, substrate concentration, temperature, and pH. And in this video, we're going to look at each of these factors in some detail. So let's start by talking about enzyme concentration. And when we have an enzyme catalyzed reaction, the concentration of the enzyme is normally very low compared to the concentration of the substrate. So when the enzyme concentration is increased, the concentration of the enzyme substrate complex is also going to increase in compliance with reaction rate theory. So remember, that in order to form our enzyme substrate complex, we take our enzyme and then we combine it with our substrate and we get our enzyme substrate complex. Okay, so this is our enzyme substrate complex. And so it stands to reason that if you were to increase the amount of the enzyme or increase the amount of substrate, you're going to increase the amount of the enzyme substrate complex. And so, based off of this, the availability of more enzyme molecules to catalyze a reaction is going to lead to the formation of more of the enzyme substrate complex and a higher reaction rate. So, again, we have the concentration of our substrate, whatever it is. And all we're saying here is if you increase the amount of enzymes, well, then you're going to have more binding sites for the substrates to go into. And so you're going to get a higher reaction rate. So the effect of enzyme concentration on the rate of reaction is shown in this figure right here. And according to the graph, the rate of the reaction is directly proportional to the concentration of the enzyme. And so let's say the concentration of the enzyme is doubled, the rate of the conversion to product is also going to be doubled. So if we take a look, let's say we have an enzyme concentration that's, let's say, somewhere around here, okay, somewhere around here on our x-axis, you see that our rate is going to be something like this. But if we double the amount of enzyme, so let's say we go over here, right? This is about twice as far, okay? Well, then if we draw a line up to our slope, okay, it's going to look something like this. And then if we draw a line over to our rate, you can see that when we went twice as much here, we ended up with twice as high a rate. Now the graph here shown, figure 12.28, shows that the concentration of the substrate significantly influences the rate of an enzyme catalyzed reaction. And so initially, the rate is very responsive to increases in substrate concentration. So you can see here at the beginning, as we increase the concentration of the substrate, right, as we increase it, you can see that the rate is going up, right? Higher concentration, higher rate. However, once you get to a certain concentration, you can see that it levels out and it stays constant. So once we get past this point right here, once we get past this concentration, you can see that it just levels off and the rate does not increase whatsoever. And this maximum rate, we symbolize this with this V max here, velocity max, and it occurs because the enzyme is saturated with substrate. It cannot work any faster under the conditions imposed. It's like if you imagine the substrate is having parking spots in a parking lot, okay, and if you imagine the substrates as being cars trying to find spaces in a parking lot, well, once all the spaces are filled up, you can put more cars in the parking lot, but they're just going to be driving around, right? They're not going to be finding parking spots. And so that's kind of what I'm using as an analogy here, right? You can increase the amount of substrate, but if there's no more parking spaces, right? If there's no more enzyme, there's no more binding sites, well, you're going to reach that maximum rate of the enzymatic, of the catalyzed reaction. Now, enzyme catalyzed reactions, just like any chemical reaction, have rates that increase with temperature. So, generally speaking, in chemistry, we say if the temperature increases, the reaction rate is going to increase. However, because enzymes are proteins, there's going to be a limit to which how much we can increase the temperature before the enzyme becomes vulnerable to what we call denaturation, right? And I used this example in a previous video where I said, if you reached into the oven by accident and, your skin touches a hot cookie sheet and then you get like a line where it gets burned or something, right? That's the proteins in your skin getting denatured. And so enzymes work the same way. Sure, you can increase the temperature, yes, and the reaction will increase. But once it gets to a certain point, you're going to break those hydrophobic interactions, the salt bridges, that hold the secondary and tertiary and quaternary structure together in your enzyme. And so then the enzyme's going to become useless. And so every enzyme catalyzed reaction is going to have an optimum temperature, which is indicated by the dashed line that you see here, right? This is the peak. This is the optimum temperature where we have the highest possible rate. And then everything after that, you can see, woo, just falls off. So above that value, we get denaturation. And below that value, well, the reaction rate's going to be lower because the enzyme still could have its temperature increased for a faster reaction rate. Now, the graph that you see here of the enzyme activity as a function of pH is pretty similar to what you saw with the temperature, where you see there's this optimum value and then it drops off after that. So you notice that the enzyme is most effective in a very narrow pH range, right? You see that this is the optimum value here, right? You have a very narrow band here where you're going to be at the top values for the rate of your enzyme catalyzed process. And so the idea is this: if you have a pH that's higher than the pH of the optimum value, or if you have a pH lower than the pH of the optimum value, then you're not going to have the optimum reaction rate. And so this variation in enzyme activity with this changing pH is probably due to the influence of the pH on the acidic and basic side chains in the active site. So in addition, most enzymes are denatured by pH extremes, right? If you think about, if you have salt bridges holding the tertiary structure together in your enzyme, well, if you change the pH, then it's going to break those salt bridges. So pickled foods resist spoilage because the enzymes of microorganisms are less active under acidic conditions. Now, there are many enzymes that have an optimum pH near 7, so essentially neutral. The pH of most biological fluids is 7. So, however, the optimum pH for a few is considerably higher or lower than 7. For example, pepsin is a digestive enzyme in the stomach and shows a maximum activity at a pH at around 1.5, right? Because we know the stomach is highly acidic. All right, example 12.8 indicate how each of the following affects the rate of an enzyme catalyzed reaction. And so we saw this, kind of generic equation that I put before. We have our enzyme plus our substrate, which can form our enzyme substrate complex. And then, of course, that can release the enzyme plus the product, right? So the enzyme goes back to being recycled all the way back to the beginning. So if we increase the enzyme concentration, well, that's going to speed up the reaction rate um, because we saw that an increase in the concentration of enzyme will increase the rate of reaction. So we'll just put here increase rate for A. And if we have an increase in substrate concentration, that's going to allow more effective collisions and thus increase the rate of reaction until the enzyme is saturated with substrate. And so we'll put here increase rate as well. So increase rate.